So the title of this talk is Blackhole Moving Goalposts. The method of science/physics is to keep moving the goalposts, i.e. keep making changes. And I'm pointing out another example of that with black holes. So I'm going to introduce the person who is going to tell us about black holes. So here we go.
I'm William Brown, scientist with the Resonance Science Foundation and faculty for the Resonance Academy.
And what he says about black holes is as follows.
Albeit the term black hole is somewhat of a misnomer because as we'll see today, black holes are the brightest objects in the known universe, as quasars and active galactic nuclei. So it's another one of those monikers in physics that kind of has the opposite name of what it should, kind of like the vacuum.
And we can look at other people who say similar, and I want to give one example of many which are saying similar to this person. So this is an article by Ethan called "Sorry, Black Holes Aren't Actually Black." And it says in the article, you might have thought that black holes truly are black, but they aren't. Along with the ideas that black holes suck everything into them and black holes will someday consume the universe, they're the three biggest myths about black holes. So black holes are not black, and I don't want to go through the article in more detail because we'll probably start picking it apart, but basically you've got this idea that black holes is now a misnomer. The point is something has been named a black hole, but it isn't really black. It's black hole is a misnomer, and the question is, how do we get into this situation? And that's because of the scientific process. This is supposed to be the scientific process, and as you can see, it's about keep going around in ever decreasing circles. You can pick it up from the top left hand box, you make observations, you then go to the next box, think of interesting questions, and then you go to the box underneath that, formulate hypotheses, and so on, keep going around in this circle. And the scientific process seems to fail when it gets to this box, and in this box the idea is to refine, alter, expand or reject a hypothesis, and often there is an alteration that takes place which is glossed over. And in the case of the term black hole, what the term means when it gets to this box can have its meaning changed from what is initially meant. Thus we end up with terms that become misnomers. Other things get changed, i.e. there are other misnomers.
The vacuum, because as we know, the quantum vacuum normally means a space completely devoid of any substance or energy or form or anything like that, but we know that the quantum vacuum is the densest material in the universe. It has the vacuum state of space has a density of something like on the order of 10 to the 93 grams per centimeter cube. So one of the most substances, one of the most highest energy densities we call empty, a vacuum. And similarly, black holes.
So the term vacuum is now a misnomer. It used to mean empty, but now in the modern context can't use it that way. So we can see the scientific process is ending up creating misnomers.
And similarly, black holes, which are normally considered, like the name would suggest, a hole that something goes into and disappears, and is black, so it's devoid of any light. Well, what we're going to look at today, and what some of the most recent research is showing, is that in fact this is absolutely not the case. Black holes have tremendous energy emissions, emissions of light across the electromagnetic spectrum, and are some of the brightest objects in the known universe. So this is kind of a change in what was the kind of conventional predominant perspective of black holes is these devouring monsters. Instead, what we're going to see is how they are much more like seeds of creation.
So black holes is now a misnomer. They're more like seeds of creation instead of destructive monsters. And you can go to the rest of the talk if you like. So the modern physics is engaged in moving the goalpost, change the meaning of words, and moves goalposts in other ways. So thank you. That's the end of this talk, pointing out how modern physics and the rest of science is engaged in this process of moving goalposts.